This video explain internal pressure when doors D1 and D2 open and other doors are closed. So in these questions we are taking two cases where the wind is coming from windward wall and D1 and D2 door are open and all D3, D4 and D5 doors are closed. So that is a case number 1. Case number A. Case number B, doors D1 and D2 are closed. So this door D1 and D2 are closed, but D3 and D5, which is leeward wall, D3 and D5 doors are open and all others door are closed. So the equation for pressure that we calculated is exactly the same, only difference that aerodynamic shape factor C fig we need to have a different for internal pressures. Now these equations that we found in the previous case, I can show it here, that we found design wind distributed pressure force, that is this P is equal to 0.196 C fig. So we are going to use the same equations. Now for this case we need to find the aerodynamic shape factor for internal pressures, that is given on the section 2.5.2a. In here we use this equation for external pressures, and now we are using this aerodynamic shape factor C fig for internal pressure, which is CPI times KCI. CPI times KCI, and that is given on page number 27 in the Australian Standard AS NZS 1170.2 2011. Now for the step number 1, for this one we need to calculate that CPI for the case 1, and to calculate the CPI we can have two tables, table 5.1a and table 5.1b, and I'm going to explain that one, which tables we can use it. Now table 5.1a is given on page number 30, and in table 5.1a it says that internal pressure coefficient CPI for the buildings where the case is for wall without opening of greater than 0.5% of the wall area and the impermeable roof. So when the building is completely closed and there is some permeable, some small gaps that allow to wind goes in that case we need to use 5.1a. So if the case is there saying that okay, all the doors are closed and we are analyzing that one, so to calculate the internal pressure in that case we need to we can extract the CPI from table 5.1a. Now table 5.1b on page number 31 is saying that when you have a opening in one of the wall, then say internal pressure coefficient for building with opening greater than 0.5 of the area of the corresponding wall or roof. So for example, if the opening is on the windward wall or leeward, this is the wind directions, or the side wall, so opening on the windward wall, opening on the side wall. So for example, where the case is when the wind is coming here, if the opening is here we need to use this case. Opening on the leeward wall we need to use this case. Opening on the side walls we need to use this case to calculate the CPI. Now we are going to use 5.1b as we have an opening on the one of the surface. So in that case we have a quick note here: ratio of the area of the opening on one surface to the sum of the total open area including permeability of other walls and roof surface. So that's I written here, exactly the same thing to explain. Now here equal to the case number 1, it's saying that door D1 and D2 is open, which is the windward wall, and door D1 has a dimension 3.6 by 4 meters. So and we have two doors, so therefore two doors times 3.6 times 4, 3.6 times 4, that's the dimension of the door, divided by this sum of the total open area. Now here it says that door for the buildings are shown and there is a fixed roof vent with a 0.13 meter airway of half length of the ridge. So this is the ridge, so in that case we can have a half of the ridge, which is 24 divided by 2 is given here, half of the length of the ridge times 0.13, so that 0.13 is coming here. So that's the sum of the total open area. In that case if you calculate this ratio it gives us 18.5, which is greater than 6. So in this case this ratio is 6 or more, so we have this case is that CPI value equal to CPE value. Now we have opening D1 and D2. We have an opening on the largest opening on the windward wall, so we're going to use this case, and we are using this one. So CPI equal to CPE. So CPI equal to CPE, and CPE for windward wall. So this is the case for windward wall, right? Because opening is on windward wall. So we need to for CPE of windward wall. So we calculate the CPE for windward wall. In the previous case, we have external pressure coefficient for windward wall. We have CPE is equal to positive 0.7. So we substitute that positive 0.7 here. And to calculate the pressures, as I mentioned, we have the same equations is equal to aerodynamic shape factors. We substitute the aerodynamic shape factor equation, CPI times KCI. So 0.96 times CPI times KCI. The combination factor is 1. So 0.96 times 0.71, it gives us 0.7 positive kilopascals. That's shown here. Positive is in these directions for the internal pressures. Now if I like to calculate the UDL load from the pressures, we calculate these pressures just now times the perpendicular length, which is 0.672 times 6 meters. Now that perpendicular length is given here, 6 meters. So if I show it here, that center to center distance is 6 meters. So for that particular frame, we are taking the percent. So if you think of pressure is generating on this wall, and if I want to create the UDL load on that surface, we need to take the perpendicular length, which is 6 meters. Now second case, door D1 and D2 are closed, which is door D1 and D2 are closed, and door D3 and D5 open. So now D3 and D5 open. Largest opening is on leeward wall. Now opening is on the leeward, wind is coming from this side. So in that case, we can have a ratio of opening, which is the area of opening. Now I can show it here. D3 has a 3.6 times 4. So D3 has a, so this is D3 door, which is 3.6 times 4, and D5 has a 1 times 2.2, 1 times 2.2, so that is your D5 door, and you sum them up to get the total area of opening on leeward wall, divided by 0.13 times 24 by 2, because it's written here we have a 0.3 airway for the half length of the ridge. So this is ridge, and halfway of the length, which is 24 meters, divided by 2, and 0.13 is the opening. That ratio gives us 10.6.6, which is greater than 6. In this case, we're going to use again table 5.1.p on page number 31, and now largest opening on the leeward wall, and it's greater than 6. So CPI is equal to CPE for leeward walls. Now this CPE for leeward walls. Now leeward walls we already calculated for this external pressure coefficient for leeward walls, and we calculated minus 0.5. So I substitute CPE is equal to minus 0.5. That's so on internal pressures, and the equation for pressure is equal to 0.96 times aerodynamic shape factors. Substitute aerodynamic shape factor CPI KC, 0.96, 0.5 CPI times 1 is give us 0.48 kilopascals, and UDL load again 0.48 kilopascals times perpendicular length, which is 2.9 kilometer per meter. Thank you very much.